Hi, I am Pouya from UCRY. Today, I'm going to talk about empirical comparison of instance attribution methods for NLP task. This is a joint work by me, Sarthak and Byron from Northeastern University, and my advisor, Singh. The goal of instance attribution methods is to identify responsible training instances for a specific target prediction. So, for example, having a trained model after getting model prediction for a specific target instance, the goal is to go through training instances and find the one that is most influential for this specific target prediction, as we can see in these images. In this work, we consider two families of instance attribution methods. The first one is similarity-based explanation. The goal here is to identify most influential training instances by identifying the one that is most similar to our target instance. To measure similarity here, we consider a few metrics such as Euclidean distance, cosine similarity, and dot product. The second family of instance attribution that we consider is data influence. The goal here is to identify the most influential training points by approximating the change in the parameters of model after removing this specific training instance and retraining the model. A famous example of this family of instance attribution methods are influence function. Here, upon having a trained model, after getting the model prediction for a specific target instance, the goal is to approximate the influence of every training instances for this specific target prediction using Hessian matrix. In this work, we consider a few variations of influence function, where the only difference there is whether they're using Hessian matrix or not using Hessian matrix, and whether they apply any form of normalization on top of their approximation or not applying any normalization. We have two fundamental motivations here. Firstly, these data influence or gradient-based instance attribution methods are expensive from computational perspective. And secondly, they have not been studied for large pre-trained language model adequately. In this work, we want to find an answer for two questions. The first one is whether simpler approximations work similar to more complex one. And by simpler here, we mean not using Hessian matrix and using fewer parameters in our approximation of influence. To find an answer for this question, we calculate correlations of pairs of attribution methods and their ranking over training instances, assessing whether simple method induced ranking similar to more complex ones. The result of a Spearman correlation over SST benchmark provided in this figure, and we can make few conclusions from this image. Firstly, we observe that we don't necessarily need the Hessian matrix. As we can see, the method that doesn't use Hessian matrix appear very similar to their counterpart that use Hessian matrix. Secondly, we observe that we don't need to use all the parameters of our classifier, which specifically here is we mean BERT classifier, and we just can use the last linear layer of our BERT in approximating of our influence. And finally, we observe that similarity-based methods are not very correlated with the gradient-based instance attribution. The second question that we want to find an answer for is how will similarity-based methods perform in comparison to the gradient-based approaches. We conduct several experiments to find an answer for this question. And the first one was to remove a portion of high influential instances for each test target, retrain the model, and observe the drop in the model prediction. The conjecture here is that the more accurate attribution method will cause more drop upon removing top influential samples. The average drop in model output over SST benchmark is provided here. As we can see, all methods seems effective compared to random sampling. Secondly, we see that surprisingly similarity-based approach perform comparably or even better than gradient-based methods. And finally, we observe that models that apply some form of normalization on top of their approximations appear more consistently throughout these experiments. The second experiment that we conduct to observe the quality of explanation in similarity-based methods was using Hans benchmark. Hans dataset was created to study existing artifacts in NLI benchmarks. And more specifically here, we focus on lexical overlap. And the conjecture here is that better attribution methods give higher influence to sample with high rate of overlap when model actually use that specific artifact in its prediction. So for example, having this example from Hans benchmark, our goal is to calculate the lexical overlap rate in influential trained instances. We see the average lexical overlap rate over Hans benchmark in this plot. As we can see, again, similarity-based methods appear better than gradient-based approaches, and it shows that they can capture this specific artifact with higher accuracy comparing to gradient-based method, which casts more doubt on the quality of explanation based on gradient-based instance attribution methods for pre-trained large language model. Thank you for your time. You can find our source code and contact information here.